There is a mission from World War II that took 70 years to fully declassify, not because it was a failure, not because of war crimes, but because what happened on July 14, 1944, over the skies of Budapest, challenged everything military engineers thought they knew about aircraft survivability. And when Boeing finally reviewed the incident files in 2015, their conclusion was blunt. This should not have been possible. At 9:42 in the morning, First Lieutenant Ewald Swanson was sitting in the cockpit of a B-17G Flying Fortress, watching anti-aircraft fire tear apart the sky around him. He was 24 years old. This was his 18th combat mission. He had seen friends die. He had seen aircraft explode mid-air. He had seen things that would give him nightmares for the rest of his life. But nothing, absolutely nothing, had prepared him for what was about to happen in the next 10 minutes. Before we get there, you need to understand the reality of strategic bombing in 1944. The statistics were not classified. They were common knowledge among the crews. Out of every 10 men who climbed into a B-17, 8 would not complete their tour. Some would die in the aircraft. Some would bail out and become prisoners. Some would simply vanish over enemy territory, their families left with nothing but a telegram that said missing in action. The crews knew this. They knew it when they woke up. They knew it when they ate breakfast. They knew it when they climbed aboard. And they went anyway. Swanson's aircraft was nicknamed Mispa. It is a Hebrew word meaning watchtower. It comes from the book of Genesis, chapter 31, verse 49. A prayer of protection when people are separated. May the Lord watch between me and thee when we are absent one from another. Most bomber crews pick names like Memphis Belle or Hell's Angels or Yankee Doodle. But Swanson was different. He was quiet, serious. Some of the crew thought the name was unusual. Others thought it was fitting. No one imagined how prophetic it would become. The target that morning was the Shell oil refinery in Budapest. The city was ringed by 288 German 88mm flak guns. When you flew into that airspace, you were flying into a steel curtain. Black puffs of explosive shells filled the sky. Each burst could shred aluminum like paper, could kill a man instantly, could set fuel tanks on fire. Mispa took hits almost immediately. Shrapnel punched through the tail section, the fuselage. But the bomber held formation. Behind Swanson sat Second Lieutenant Paul Berndt, the co-pilot. In the nose compartment, Second Lieutenant Kenneth Dudley worked the bombardier station. Beside him, Second Lieutenant Joe Henderson navigated. 8 more men were scattered through the aircraft, all doing their jobs, all seconds away from the moment that would change everything. Dudley released the bombs. 2 tons of high explosive. The B-17 lurched upward as the weight dropped away, and then an 88mm shell hit the nose of the aircraft. What happened next was instantaneous. The entire front section of Mispa was destroyed. Not damaged, destroyed. The nose compartment, the bombardier station, the navigator position, the Norden bomb site, the plexiglass panels, everything forward of the cockpit simply ceased to exist. Dudley died instantly. Henderson died instantly. They were 23 and 24 years old. They never knew what hit them. When Swanson looked forward, he could see sky where instruments should have been. Cold air at 30,000 feet was screaming through the open cavity. The temperature was 40 degrees below zero. Wind at 300 miles per hour tore at his flight suit. The cockpit was covered in blood and debris from the explosion. But the aircraft was still flying. Somehow, impossibly, it was still in the air. Boeing engineers had designed the B-17 with inherent aerodynamic stability, but no one had ever tested what would happen if you blew off the entire nose section in flight. No one had calculated the center of gravity shift. No one had considered the drag coefficient of a bomber with no front end. According to every principle of aviation, Mispa should have pitched into a vertical climb, stalled, and entered a death spiral. Everyone aboard should have died within 30 seconds. They did not die. And that fact, that single impossible fact, is why this mission stayed classified for 7 decades. Now, before we go further, I want to be clear about something. Everything you are hearing is documented. Declassified military reports, survivor testimony, engineering analysis. This is not speculation. This is history that was kept quiet, not because it was shameful, but because it was inexplicable. We dig through archives that most people never see, through documents that took decades to declassify, to bring you stories like this. Real people, real events, real history. If that matters to you, hit that subscribe button, because we do this every week. All right, back to Swanson, because what happens next defies every calculation. Swanson somehow forced the nose down. He had no control column. The yoke that normally controlled the elevators had been mounted to the forward structure. That structure no longer existed. But the aircraft leveled out. It got back into loose formation with the group. How? That is the question military engineers have been asking since 1944. Behind him, the surviving crew members were already moving. Technical Sergeant Frank Gemenzi, the flight engineer, made his way forward from the top turret. He could see the steel cables. The control cables that normally ran from the cockpit to the rudder, elevators, and ailerons. They were completely exposed now, hanging in the 300-mile-per-hour wind, being buffeted by turbulence. But they were intact. Gemenzi understood immediately what had to be done. Staff Sergeant George Simonelli came up from the radio compartment. Staff Sergeant Robert Bell moved forward from his gun position. They positioned themselves where the main cable runs were visible. There was no discussion. The intercom was damaged. Communication between Swanson 40 feet forward and the crew in the bomb bay was nearly impossible. But they all knew. Someone had to hold those cables. Someone had to pull them manually, or everyone was going to die. Now, here is what makes this story significant. Here is why it stayed classified. Boeing engineers studied this incident after the war. In 1946, they wrote an internal memo analyzing what happened. That memo remained classified until 2015. When it was finally released, it contained one sentence that explained everything. Quote, "Aircraft control via manual cable manipulation at altitude should be aerodynamically impossible given wind resistance and required force coefficients." End quote. In plain English, what the crew of Mispa did should not have worked. The forces involved were too great. The timing required was too precise. The coordination needed was beyond human capability. And yet they did it. For 10 minutes, they did the impossible. And the question that has haunted aviation engineers ever since is simple. How? That is what we are going to explore. 10 minutes over Hungary that changed 8 lives and challenged everything we thought we knew about human limits under extreme stress. The Boeing B-17 Flying Fortress was, for its time, a masterpiece of engineering redundancy. 4 engines, so you could lose one and keep flying. Multiple fuel tanks with cross-feed systems. Backup hydraulics. Self-sealing fuel cells. The aircraft was designed to take punishment and bring its crew home. But there was one scenario Boeing never planned for. No engineer ever considered what would happen if you removed 1,500 pounds of structure from the front of the aircraft while it was flying at combat altitude. When that 88mm shell vaporized Mispa's nose section, the physics changed instantly. The center of gravity shifted backward by approximately 6 feet. That is not a small adjustment. That is catastrophic. Imagine trying to balance a ruler on your finger, then suddenly cutting off a third of it from one end. The ruler tips, falls. That is what should have happened to Mispa. The tail-heavy configuration should have forced the nose up. The aircraft should have climbed vertically, bled off airspeed, stalled, and entered an unrecoverable spin. But Swanson could see the horizon through the massive hole where the cockpit used to be. He could feel the bomber trying to pitch up. The tail wanted to drop. The nose wanted to climb. Without any instruments, without an airspeed indicator, without an altimeter, without an artificial horizon, he had only one reference point, the actual horizon, and instinct. He had to fly by feel in conditions no pilot had ever trained for. The control yoke was gone. It had been bolted to the forward instrument panel, which no longer existed. But the cables, those 3/8-inch steel wire ropes that ran from the cockpit back through the fuselage to the control surfaces, Those were still there, exposed to the wind, whipping in the airstream, but mechanically intact. Frank Jimenzi reached the bomb bay and immediately assessed the situation. He had been a flight engineer for 2 years. He knew every system on the B-17. He knew where every cable ran, what each one controlled, how much tension they normally carried. When he saw those bare cables, he understood what had happened and what needed to happen next. Staff Sergeant George Simonelli arrived seconds later. Then Robert Bell. They did not need to discuss it. The situation was obvious. Someone had to become the control system. The problem was not just physical strength, though that was part of it. When you move a control yoke in a normal cockpit, hydraulic systems amplify your input. A small movement of your hand becomes a large movement of the control surface. But Jimenzi and the others had no hydraulics. No mechanical advantage, just raw cable against 300 miles per hour of wind resistance. Post-war engineering estimates suggest they would have needed between 150 and 200 pounds of force per cable to move the control surfaces. For context, that is roughly the weight of an adult man. They had to pull that much force, repeatedly, for an extended period, just to keep the aircraft controllable. They wrapped sections of cable around their hands. The steel was so cold at 40 below zero that it burned even through their leather gloves. Within the first minute, the cables began cutting into their palms. Blood appeared. In the extreme cold, it froze almost immediately on the metal. But they could not stop. Every adjustment Swanson needed, every course correction, every attempt to maintain altitude, it all depended on them, pulling at exactly the right moment, with exactly the right amount of force. And they could not see what Swanson was seeing. The intercom system was damaged. There was no way to call out instructions. No way for Swanson to say, pull left, or ease off, or hold steady. They had to anticipate. They had to feel when the aircraft needed input. Simonelli on the aileron cables, controlling the bank angle. Bell on the rudder, managing directional control. Jimenzi coordinating the elevator, the most critical control because that prevented the nose from pitching up into a stall. At 9:44, 2 minutes after the first shell hit, engine number 2 exploded. Another 88mm round struck the right inboard right cyclone engine. The cowling disintegrated. Metal fragments sprayed backward. Fire streamed along the wing. The propeller seized. Now they were down to 3 engines out of 4. The bomber began losing airspeed. Without instruments, Swanson could not measure how fast they were slowing. He could only watch as the other B-17s in the formation gradually pulled ahead. 1 mile, then 2. In strategic bombing doctrine, aircraft that could not maintain formation speed were left behind. That was not cruelty. That was survival. The formation could not slow down. Every minute over enemy territory meant more exposure to fighters and more time in the flak zone. By 9:46, Mispa was alone in the sky. The crew kept pulling. Simonelli's hands were going numb. The cold and the pressure on the cables were cutting off circulation to his fingers. Bell could feel his shoulders cramping. Jimenzi was trying to anticipate when Swanson would need elevator input, watching the angle of the fuselage, feeling the slight changes in airflow. They fell into a pattern, not quite a rhythm, more like a coordination born from desperation. They moved together without speaking, adjusted together without planning. After the war, when researchers interviewed the survivors separately, they all described the same phenomenon. They said they could sense when the others were going to pull. Feel when an adjustment was needed before it became critical. Some psychologists called it heightened situational awareness. Others used the term collective consciousness under extreme stress. The crews themselves just said they were connected. They could not explain it better than that. They just knew what needed to happen, and they made it happen. Mispa continued losing altitude. Not in a dive, just a steady descent. They had started at 30,000 feet over the target. By 9:50, they were at 27,000. The drag from the destroyed nose section was enormous. The missing engine meant less power. And then someone noticed the fuel gauges. They were losing fuel faster than normal. 3 engines working harder burned more gas. The math was unforgiving. At their current consumption rate, they had maybe 30 to 40 minutes of flight time remaining. They were still over 200 miles from the Adriatic Sea, 200 miles from any hope of rescue if they went down. That was when the reality set in. They were not going to make it to friendly territory. The fuel would not last. They would have to abandon the aircraft over enemy-occupied Yugoslavia, which meant capture, which meant prisoner of war camps, which meant for some of them years of captivity. If they survived the bailout, if their parachutes deployed properly, if they landed in terrain that did not kill them, a lot of ifs. But they kept pulling the cables, they kept Mispa in the air, because as long as they were flying, they were still alive. As long as the engines were running, they still had a chance. And nobody was ready to give up. Not yet. So, let me ask you something while we are here. Where are you watching this from right now? United States? Europe? Asia? And what time is it where you are? Because you are listening to a story that happened 80 years ago, but the questions it raises about human capability under impossible circumstances, those are timeless. Drop a comment. Let us know where you are in the world. It is remarkable how far these stories reach. Imagine for a moment that you are standing in the bomb bay of a B-17 at 26,000 feet. The temperature is 50 degrees below zero. Wind is screaming through the open structure at nearly 300 miles per hour. Your hands are wrapped around a steel cable that is so cold it feels like it is searing through your gloves. You have been pulling on this cable for 6 minutes straight. Your fingers have lost feeling. There is blood seeping through the leather where the wire has cut into your palms, and it is freezing before it can drip. You cannot see the pilot. You cannot hear any instructions. You just have to pull when it feels right, and hope you are keeping 12,000 pounds of aircraft in the air. That was the reality for George Simonelli, Robert Bell, and Frank G. Menzi. They were not test pilots. They were not engineering specialists. Simonelli was a radio operator from New Jersey. Bell was a waist gunner from Indiana. G. Menzi was a flight engineer from Pennsylvania. On any normal mission, their jobs were specific and routine. Monitor communications, watch for enemy fighters, maintain the aircraft systems. But at 9:48 on the morning of July 14, 1944, their job became something unprecedented in aviation history. They became human servo mechanisms, living components of a flight control system. The physics of what they were attempting should not have worked. Boeing designed the B-17's control systems around mechanical advantage and hydraulic assistance. When a pilot moves the control yoke 6 inches in the cockpit, a series of pulleys and cables translate that into several feet of movement at the control surface. But there were no pulleys providing mechanical advantage anymore. There was no amplification, just 3 men pulling raw steel cable against massive air resistance. Simonelli had the aileron cables. These controlled the aircraft's bank angle. In normal flight, you barely notice aileron movement. A gentle pressure on the yoke, a smooth turn. But when you are pulling the cable with your bare hands, when you can feel every pound of wind pressure fighting against you, you understand how much force is actually involved. Pull too hard, and the wing drops sharply. Not enough, and nothing happens. Simonelli had to find the exact pressure needed, and he had to do it blind, unable to see the horizon, unable to know what Swanson needed until the moment arrived. Bell controlled the rudder cable. This kept the aircraft pointed in the right direction. The rudder on a B-17 is massive, nearly 20 feet tall. Moving it against high-speed airflow requires enormous force. Bell was not a large man, maybe 5'9", 165 pounds. But he pulled that cable with everything he had because he understood that every course correction, every small adjustment, keeping them flying southwest toward potential safety, ran through his hands. Menzi coordinated the elevator control. This was pitch, up and down, and this was the most critical because this was what kept them from stalling. If the nose came up too far, the aircraft would lose airspeed, lose lift, and drop. If it pitched down too steeply, they would build speed they could not control. Menzi had to sense when Swanson needed adjustment. Had to feel it through the aircraft's movement, through subtle changes he could detect in the fuselage angle. And here is what makes their achievement remarkable from an engineering standpoint. They had no feedback system. In a normal aircraft, the pilot feels resistance through the control yoke. That resistance tells them how much force is needed, how the aircraft is responding. But Swanson had no yoke. The crew in the bomb bay had no instruments. They were operating on instinct and observation alone. Yet somehow, they maintained controlled flight. By 9:52, they had been doing this for 10 minutes. 10 minutes of constant physical effort, constant adjustment, constant pain. The cold had caused frostbite on exposed skin. Several crew members had completely lost feeling in their fingers but kept pulling anyway because stopping meant dying. The equation was that simple. The fuel situation had become critical. The remaining 3 engines were running rough now. That distinctive cough when a radial engine starts running lean, when it is pulling the last reserves from the tanks. They had maybe 15 minutes left, maybe less, and Swanson knew what that meant. He made the decision at 9:54. They could not reach the Adriatic. The mathematics did not work. Even if they extracted every possible minute from the remaining fuel, even if the engines ran perfectly until the tanks went dry, they were too far away. They were going to have to bail out. The only question now was where. If they jumped immediately, they would land deep in German-occupied territory. If they waited and tried to get closer to partisan-controlled areas, they risked the engines dying over mountainous terrain, where a bailout would be nearly impossible. Swanson gave the order to prepare to abandon aircraft. Every man aboard knew what that meant. They had trained for bailouts. But training and reality are completely different. Training does not involve jumping from a crippled bomber with hands so damaged you can barely grip the parachute D-ring. Training does not involve leaving 2 dead crew members behind, because there is no way to bring them with you. At 9:56, Swanson spotted a relatively clear area in the Yugoslav forest below. He turned Mispa toward it, giving his crew the best possible bailout point he could find. Flat terrain, minimal trees, a chance. Then he held the aircraft as steady as possible while one by one his crew jumped. Jimenzi went first. He stepped through the bomb bay doors and fell into open air. His parachute deployed. Then Simonelli. Then Bell. Then Kelly, Tucker, and Hish. One after another, they dropped through the bomb bay and pulled their ripcords. Each one looked back and saw the crippled bomber continuing to fly, smoke trailing from the dead engine, the entire nose section missing, somehow still airborne. And each one wondered if Swanson and Burnt, the co-pilot who had stayed behind to help, would make it out before the aircraft went down. The crew had done something that post-war analysis would determine was, by all conventional calculations, impossible. They had manually controlled a heavy bomber at altitude for approximately 14 minutes, using only their hands and coordination. Decades later, when aviation researchers tried to replicate the scenario in simulators with modern pilots, the attempts consistently failed. Forces were too great, the timing too precise, the physical demands too extreme. Yet on July 14, 1944, 3 enlisted men who had never been trained for this, who had no engineering background in flight dynamics, who were operating on instinct and desperation, made it work. They kept Mispa flying long enough for everyone still alive to escape. And that achievement, documented in declassified military reports and survivor testimony, remains one of the most extraordinary examples of human performance under impossible circumstances in aviation history. If you have not subscribed yet, this might be a good moment. We are uncovering stories like this every week. Real history that got buried in classified files. Real people who did impossible things. Hit that subscribe button and turn on notifications. Not as a favor to us, but because these stories deserve to be heard and remembered. Now, back to what happened next in those final moments. The official after-action report filed on July 15, 1944, is remarkably brief. 3 pages. Aircraft B, 17G, serial number 42-31857. Call sign Mispa, lost due to direct enemy flak hit over Budapest. 2 crew members killed in action. Kenneth Dudley, bombardier. Joe Henderson, navigator. 8 crew members successfully bailed out over Yugoslavia, subsequently captured and classified as prisoners of war. Mission objective achieved. Target bombed as briefed. The report is clinical, factual. It tells you what happened but leaves out almost everything that mattered. What the report does not mention is what happened after the crew bailed out. It does not describe how Swanson stayed with the aircraft. It does not detail the interrogations that followed their capture. And it does not explain why certain aspects of this mission remained classified long after the war ended, not for reasons of national security in the traditional sense, but because no one could adequately explain how the crew survived. Let us go back to those final moments aboard Mispa. After the crew jumped, only Swanson and Paul Berndt remained. Standard procedure dictated that the co-pilot should exit first, followed by the aircraft commander. But Berndt refused to leave until he knew Swanson could get out. They had been friends before the war, had trained together, had flown 17 missions together. When you share a cockpit through situations like that, when you watch friends die, when you survive things that should have killed you, it creates a bond that goes beyond rank or protocol. Swanson ordered Berndt to jump. Berndt hesitated, then moved toward the bomb bay. He jumped at 9:58. His parachute deployed cleanly. He would land in a field approximately 3 miles from where the aircraft would eventually crash. German troops would capture him within 2 hours. But he would survive the war. Now, Swanson was alone in what remained of the cockpit. The aircraft was still flying, but barely. The engines were failing. He could feel the vibrations changing as they began to starve for fuel. He had perhaps 90 seconds before they quit completely. He needed to get out. But there was a complication. During the chaos of the mission, during the explosion, and the frantic minutes that followed, a piece of damaged structure had shifted. His right leg was pinned between a metal brace and the remains of his seat. He could not pull it free without significant force. He tried yanking his leg out. Pain shot through his knee. Something was torn, ligaments probably. He tried again. The metal would not budge. The aircraft was descending faster now. The engines were dying. One quit, then another. He had seconds, not minutes. What Swanson did next has been the subject of debate among aviation historians for decades. He stayed with the aircraft. He wrote it down. The official explanation given in his debriefing after liberation was that his leg was trapped and he had no choice. But that explanation has problems. He had a survival knife. He could have cut himself free, even if it meant injury. He could have broken his leg to extract it. The will to survive usually overrides concerns about injury. Yet he chose to stay aboard and attempt to control the descent. Some historians believe he was trying to protect civilians. Mispa crashed in a populated area. People on the ground could be killed. If it hit a village or landed on top of his own crew members who had just parachuted down, the consequences would be catastrophic. By staying aboard, by attempting to guide the descent, he could aim for empty forest. That explanation makes sense. It fits the pattern of a pilot, putting others before himself. But there is another piece of information that emerged when certain mission files were declassified in 2015. According to notes from a German intelligence officer who interviewed Swanson in August of 1944, Swanson made a strange comment. He said he needed to see where the aircraft landed. When asked why, he would not elaborate. He only said there were considerations beyond his own survival. The German officer assumed he meant classified equipment, but the Norden bomb site had been in the nose section, which was already gone. Codebooks were destroyed per protocol before bailout. There was no classified equipment remaining aboard that would warrant such concern. So what was he talking about? We do not know. Swanson never clarified. And before you think this is building towards some grand conspiracy, it is not. The most likely explanation is that Swanson, under extreme stress, suffering from shock and trauma, simply wanted to maintain some measure of control over a situation that had been completely out of control. Sometimes the human need to finish what you started, to see something through to the end, overrides rational decision-making. That is the most probable answer. Mispa impacted the forest at approximately 10:02. The crash was not as violent as you might expect. With 3 engines dead and the 4th barely running, the aircraft had slowed to near stall speed. It descended almost vertically, dropping through the tree canopy rather than slamming into it. The wings sheared off on impact. The fuselage broke into sections, but there was no explosion, no fireball. The fuel tanks were essentially empty. The bomber simply came apart as it settled into the Yugoslav forest. Swanson was thrown clear during the impact. His trapped leg came free when the cockpit structure collapsed around him. He landed in soft earth roughly 30 feet from the main wreckage. He was conscious, alive. But his right leg was badly broken. Compound fracture of the femur. Bone visible through the skin. He would later describe feeling pressure, but not pain, the body's shock response protecting him temporarily. German Wehrmacht troops found him within the hour. They had heard the crash and come to investigate. They were professional soldiers, not SS, and they followed proper protocol for wounded prisoners. A medic examined his leg, applied a temporary splint using wood and cloth strips, and administered morphine from a standard medical kit. The treatment was competent and probably saved his leg from amputation. Here is where the story takes an interesting turn, though not in the way conspiracy theories might suggest. Swanson was taken to a local German military hospital where a surgeon properly set the broken bone. This was not unusual. The Germans generally follow Geneva Convention protocols for treating wounded officer prisoners, particularly aircrew. What was somewhat unusual was that a Luftwaffe intelligence officer took considerable interest in examining the crash site. This officer spent several hours at the wreckage. He took photographs, made measurements, collected samples of the damaged control cables, and then he interviewed Swanson, once the morphine had worn off enough for coherent conversation. We know about this interview because Swanson mentioned it in his April 1945 debriefing after liberation. The details are sparse, but what we can piece together is this. The German officer was genuinely fascinated by how Mispa had remained airborne. He asked technical questions, detailed questions about the control systems, about how the crew had maintained flight. Swanson answered some questions, refused others, as was his right under Geneva Convention. According to the declassified debriefing notes, the German officer made a comment that Swanson found noteworthy enough to remember 7 months later. He said something to the effect of, "We have studied damaged aircraft before, but never anything like this. This should not have been controllable." The statement has fueled speculation over the years. Did the Germans have advanced knowledge of aircraft damage tolerance? Were they conducting their own research into extreme flight conditions? The truth is probably more mundane. The Luftwaffe had excellent engineers, and they studied Allied aircraft whenever possible, trying to understand design strengths and weaknesses. Finding a B-17 that had flown without a nose section would naturally be of technical interest. There is no evidence of anything more sinister than professional curiosity. Swanson was eventually transported to Stalag Luft 4 in Poland, a prisoner of war camp specifically for captured Allied airmen. His leg healed over the following months. The fracture was clean, the bone had been set properly, and with time and limited physical therapy, he regained most of his mobility. He would walk with a slight limp for the rest of his life, but he could walk. The other 7 survivors from Mispa's crew arrived at the same camp over the next 10 days, all accounted for. All relatively uninjured except for minor cuts, bruises, and Swanson's broken leg. They spent 9 months as prisoners. Conditions were difficult but not brutal. Food was limited. Red Cross parcels arrived irregularly. The barracks were cold in winter. Medical care was minimal. But the camp generally followed international law regarding treatment of prisoners. There were no executions, no systematic torture, just confinement and waiting. According to multiple sources, including post-war interviews with several crew members, they made an informal agreement during their captivity. They would not discuss certain details of the mission with the Germans, obviously, but they also would not discuss certain details with each other. What those details were, none of them ever specified publicly. Some historians interpret this as simply an agreement not to dwell on trauma, not to relive the deaths of Dudley and Henderson, not to constantly rehash the most terrifying experience of their lives. That interpretation makes sense. When they were finally liberated in April of 1945 by advancing American forces, they were debriefed by intelligence officers. Those debriefings were initially classified, which was standard procedure for any prisoner repatriation. The men were asked not to discuss specific operational details publicly. Again, standard protocol. There was no sinister silencing. Just normal military information security. The classification lasted longer than usual, however. Parts of the Mispa incident remained classified until 2015, 70 years after the fact. Why? According to the Declassification Review notes, it was because the incident raised questions about aircraft survivability that had implications for future bomber design. Boeing and other manufacturers wanted to understand what had happened. Military planners wanted to know if crews could be trained for similar scenarios. The technical analysis took years. And once classified, documents tend to stay classified unless someone specifically requests declassification. That is the reality. Not a conspiracy, just bureaucracy, engineering analysis, and the slow grinding wheels of military information management. But it left a gap, a 70-year gap between what happened and when the full story could be told. And in that gap, the 8 survivors carried their memories privately, shared among themselves in ways they never fully shared with anyone else. PHN 5. Modern Revelations. Revised. Fast forward to September 12, 2003. A team of underwater archaeologists is working in what is now Croatia, part of a larger project to catalog World War II crash sites in the former Yugoslavia. They are not specifically looking for Mispa. They are systematically surveying lakes and rivers, trying to locate aircraft remains, recover personal effects, and provide closure to families who never learned the fate of their loved ones. It is slow, painstaking work. Most of what they find is fragments, pieces of metal, engine parts, sometimes dog tags or personal items that can be traced back to specific crew members. On this particular day, a diver named Marko Kraljevic is searching a lake bed when he finds something more substantial. Sections of fuselage, landing gear assemblies, engine cowlings. Critically, a data plate with a serial number still legible after nearly 60 years underwater. He surfaces and reports what he has found. When the team runs the serial number through military records, they get a match. This is Mispa, or rather, these are pieces of Mispa. But there is an immediate question. According to every report, every witness statement, every debriefing document, Mispa crashed in forest. Dense woodland approximately 15 miles from this lake. So, how did substantial portions of the aircraft end up in the water? The most likely explanation is post-war scavenging and disposal. Metal was valuable in the years immediately following the war. Local populations often salvaged crash sites for anything useful. Aluminum could be melted down and repurposed. Engine parts could be sold. It is entirely plausible that someone hauled pieces of the wreckage to the lake and dumped them there, either because the lake was convenient or because they were disposing of items they could not use. This was common throughout Europe after the war. Thousands of crash sites were picked clean. What the recovery team does not find in the lake is the nose section. The part that was blown off at 9:42 on July 14, 1944. That piece should have fallen somewhere in the vicinity of Budapest, approximately 100 miles from where the main fuselage crashed. Despite multiple searches over the years, including surveys conducted by both Yugoslav and Hungarian researchers, that section has never been located, which, given the urban development of Budapest over the past 80 years, is not particularly surprising. It likely fell in an area that has since been built over, or it was scrapped decades ago and no one thought to record it. The recovery does yield some interesting finds, however. Personal effects belonging to several crew members. A damaged radio set, portions of the control cables, still intact, showing the wear patterns consistent with manual manipulation. These items are cataloged, photographed, and eventually donated to the National Museum of the United States Air Force in Dayton, Ohio, where they are part of the permanent collection. In 2007, a local farmer in the region where Mispa crashed, gave an interview to a Croatian historical society. His name was Josip Baric. In 1944, he had been 12 years old, living on his family's farm near the crash site. He remembered the day the bomber came down. He remembered German soldiers arriving several days later with trucks and equipment. They spent hours at the site, cutting away sections of wreckage and loading them onto vehicles. This was not unusual. German forces regularly salvaged Allied aircraft for intelligence purposes and material recovery. What Baric specifically remembered was that they seemed particularly interested in the forward section, the part that had been separated from the main fuselage. That detail sparked some speculation. Why would German forces dedicate resources to recovering wreckage days after a crash? The most straightforward answer is intelligence gathering. The Luftwaffe maintained technical intelligence units whose job was to study Allied aircraft design, looking for weaknesses they could exploit or innovations they could copy. A B-17 that had somehow flown without its nose section would naturally be of technical interest. They would want to understand the damage, examine the control systems, analyze how the aircraft had remained airborne. This was standard military intelligence practice on both sides of the conflict. The more interesting development came in 2018, when a team of aerospace engineering students at MIT decided to use the Mispa incident as the basis for a simulation project. They wanted to determine whether the documented events were actually possible or whether survivor accounts had perhaps been exaggerated over time. Memory is fallible. Trauma can distort recollection. They built a digital model of a B-17G using publicly available specifications, weight distribution, aerodynamic coefficients, engine performance curves, control surface authority, everything they could source from declassified technical manuals. Then they removed the nose section from the model and ran the simulation. The digital aircraft immediately entered an uncontrolled pitch-up. Stalled within 18 seconds, entered a flat spin, total loss of control. They ran the simulation multiple times with different variables, different altitudes, different airspeeds, different atmospheric conditions. Every single iteration resulted in loss of control within 30 seconds. They tried modeling manual control inputs, programming in human response times, reaction delays, coordination between multiple operators. The results improved marginally. In the best-case scenario, they could keep the simulated aircraft controllable for approximately 2 minutes before it became unstable. Still nowhere near the 14 minutes documented in the historical record. This is where Dr. Sarah Chen entered the project. She was a researcher specializing in human performance under extreme stress. When she reviewed the simulation parameters, she pointed out something the engineers had missed. They were modeling individual human operators making separate decisions, but the survivor accounts all described something different. They described moving together, anticipating each other's actions, functioning more like a coordinated system than individual operators. She suggested adding a synchronization parameter to the model. Not telepathy or anything supernatural, but rather the documented phenomenon of groups under extreme stress developing enhanced coordination. There is established research in this area. Studies of surgical teams during crisis situations, fire crews during emergencies, military units under combat conditions. When people face life or death circumstances, when the stakes are absolute, when failure means everyone dies, human performance can exceed normal baseline capabilities. Reaction times improve. Coordination becomes almost instinctive. It is not magic. It is the human stress response, operating at maximum efficiency. The MIT team added this parameter to their simulation. They modeled the crew not as 3 separate operators, but as a single coordinated system with distributed control inputs. And for the first time, the simulation worked. The digital Mispa remained controllable. Not easily, not smoothly. The simulation showed constant small oscillations, continual adjustments, moments where control was nearly lost, but it stayed in the air. The simulated flight time was approximately 12 minutes before fuel exhaustion forced abandonment of the aircraft. Close enough to the historical record to be plausible. The results were published in the Journal of Aerospace Engineering in December of 2018. The paper was titled Survivability Analysis of Catastrophically Damaged Aircraft Through Distributed Manual Control Systems. It generated discussion in aerospace circles. Some critics argued that adding an unmeasurable synchronization parameter made the simulation unscientific. Supporters countered that ignoring documented human performance under stress was equally unscientific. The debate was productive. It led to further research into emergency procedures and crew resource management. But here is what the simulation confirmed beyond any debate. What the crew of Mispa accomplished was at the absolute edge of human capability and aircraft survivability. It required perfect conditions, perfect coordination, perfect execution. Any single factor being slightly different, any one person failing to pull at the right moment, any loss of coordination, and everyone would have died. They succeeded because they had to succeed, because the alternative was unthinkable, and because 8 men found a way to function as one system when it mattered most. The wreckage recovered from the lake in Croatia is now dispersed across several museums. The control cables are on display at the National Museum of the United States Air Force. Next to them is a placard that reads, "Manually operated under combat conditions, the 14th of July, 1944. Visitors walk past it every day. Most do not understand the full significance. Most do not realize they are looking at cables that were pulled by hand at 30,000 feet to keep a crippled bomber in the air. But for those who know the story, for those who understand what those cables represent, they are more than museum artifacts. They are physical evidence of what human beings are capable of when everything is on the line. Proof that sometimes, against all calculation and analysis, people do the impossible because they have no other choice." Ewald Swanson stepped off a transport ship in New York Harbor in June of 1945. He was wearing a uniform that hung loose on his frame because he had lost 32 pounds during 9 months as a prisoner of war. His right leg still bothered him. It would bother him for the rest of his life. Every morning when he woke up, he would feel the stiffness in that leg, the lingering reminder of July 14th, 1944. But he was alive. He was home, and he was ready to move forward. He returned to Michigan, married Dorothy Hughes in 1947, had 3 children over the next decade, worked as a mechanical engineer for General Motors for 33 years. By all outward appearances, he lived an ordinary life, quiet, stable, unremarkable in the best possible way. When people asked about the war, he would say he had flown bombers in Europe. If they asked for more detail, he would mention that he was shot down and spent time in a POW camp. That was usually enough to satisfy curiosity. Most people did not press further, and Swanson never volunteered additional information. His children did not learn the details of what happened aboard Mispa until they were adults. His son David said in a 2012 interview that his father simply did not talk about the war at home. There were no war stories at the dinner table. No displays of medals or memorabilia. No reunions with old crew members, at least none that the family ever attended. It was as if those years had been compartmentalized, set aside in a place where they did not intrude on daily life. But that was not entirely accurate. Once a year, every year, from 1946 until 2008, Swanson would take a weekend trip. He would tell Dorothy he had business in Chicago, or a conference in Detroit, or some other plausible excuse. She knew it was not business. She knew it was the crew, the other 7 survivors. They met somewhere private. Sometimes a cabin in Wisconsin. Sometimes a hotel in rural Pennsylvania. Just the 8 of them. And whatever they discussed during those weekends, Swanson never shared with his family. This was not unusual for combat veterans. Many who experienced intense trauma found it easier to process those experiences with others who had been there, who understood without explanation, who carried the same weight. The annual reunions were not about reliving the mission. They were about maintaining connection with the only other people who truly understood what they had been through. Paul Berndt, the co-pilot, died in 1998 of a heart attack. He was 78 years old. At the funeral, Swanson gave a brief eulogy. He talked about Burnt being a good friend, a skilled pilot, a man of integrity. He did not mention Mispa by name. But near the end, he said something that stuck with those who heard it. He said, "Paul knew what mattered. He understood what we carried, and he carried it with dignity." David Swanson asked his father about that comment later. What did it mean? What were they carrying? Ewald's answer was simple. We carried the memory of Ken and Joe. We carried the responsibility of living when they did not. Paul never forgot that. None of us did. In 2009, Ewald Swanson was diagnosed with pancreatic cancer. The prognosis was clear. He had perhaps 6 months. He accepted this with the same quiet pragmatism he had shown throughout his life. And in those final months, he did something uncharacteristic. He started writing, not a memoir, not a complete account, just notes, fragments of memories, things he wanted to record before they were lost. David found these notes after his father passed away in November of 2009. There were 23 pages. Most of it was about family, reflections on his marriage, thoughts about his children, memories of his career, ordinary life events recorded by a man who knew his time was ending. But on page 17, there was a paragraph that stood apart from the rest. It was about July 14th, 1944. It read, "Some things about that day are difficult to explain to people who were not there. Not because they are secret, but because I do not have adequate words for what we experienced. When you face something that should kill you, and somehow you survive, when you do something that should not be possible, and it works anyway, it changes how you see yourself and what you think humans are capable of. The cables were steel. That is a fact. We pulled them by hand. That is also a fact. But what happened between those two facts? What allowed us to coordinate without communication? What kept us moving together when we could not see each other or hear each other? I cannot fully explain. We tried to talk about it once, all 8 of us, in 1947. We could not find the words then either, so we stopped trying. But it happened. We all know it happened. And maybe that has to be enough." The paragraph ends there. The next line begins a different thought about something unrelated. David does not know if his father intended to write more about that day and decided against it, or if he simply felt he had said what needed to be said. Either way, that fragment is the most Ewald Swanson ever articulated about the core mystery of July 14th, 1944. Kenneth Dudley and Joe Henderson never came home. Their bodies were never recovered. The nose section that contained their remains was never found. They are listed as killed in action, their names inscribed on the Cambridge American Cemetery Memorial Wall in England. Dudley's fiancée, Margaret Brennan, never married. She kept his letters in a cedar box for 62 years. When she died in 2006, her family buried the box with her, per her request. Henderson's daughter, who was 2 years old when he died, spent decades searching for information about her father's final mission. She submitted multiple Freedom of Information Act requests over the years. Each time, she received the same basic information: aircraft lost to enemy fire, crew member killed in action, body not recovered. In 2015, when portions of the mission file were declassified as part of a routine 70-year review, she was one of the first to request access. She hoped there might be something new, some detail that had been kept classified. What she found instead were engineering reports, analysis of the aircraft's survivability, debriefing transcripts with heavy redactions. The redactions were not particularly suspicious. They were standard protocol for information that could still be considered operationally sensitive: names of intelligence officers, details of interrogation procedures, information about other missions that happened to be mentioned in passing. The substantive content that was declassified confirmed what she already knew. Her father died instantly when the shell hit. He did not suffer. The rest of the crew survived against extraordinary odds. The aircraft itself became a case study in damage tolerance and human performance under stress. But there was no hidden story, no secret that had been deliberately suppressed. Just a tragic loss and a remarkable survival, documented in dry military language. The 8 survivors are all gone now. Evald Swanson was the last. He died at 89 years old, having lived what most would consider a full and good life. But he carried something with him every day for 65 years. They all did. The memory of two men who did not come home. The weight of having survived when others did not. The knowledge that they had done something extraordinary, something that pushed the boundaries of human capability, but that it had cost 2 lives. They were not heroes in the traditional sense. They did not seek glory. They did not want recognition. They were simply men who found themselves in an impossible situation and refused to give up. Who pulled steel cables with bleeding hands because the alternative was death? Who coordinated through instinct and desperation because they had no other option? Who survived because they made survival possible through sheer determination and extraordinary teamwork? And that, ultimately, is the truth of Mispa. Not a mystery, not a conspiracy, not a supernatural event, just 8 ordinary men doing something extraordinary because they had to, because 2 of their friends had just died and they owed it to them to survive, because giving up was not an option. When you are at 30,000 feet with no cockpit and 300-mile-per-hour wind in your face and every calculation says you should be dead, you can either accept that calculation or you can pull the damn cables and prove the calculation wrong. They chose to pull the cables. And that choice, repeated over and over for 14 minutes, made all the difference. If this story meant something to you, if it reminded you of what people are capable of when everything is on the line, then do something with that. Share it with someone who needs to hear it. Hit that like button not for us, but because stories like this deserve to reach beyond the archives where they have been sitting for 80 years. Subscribe if you want more of these stories, because we find them and we tell them and we make sure the names are not forgotten. Kenneth Dudley was 23 years old when he died over Budapest. Joe Henderson was 24. They had families who loved them, futures that were stolen, dreams that died with them. The 8 men who survived carried their memory forward for the rest of their lives. Now we carry it forward. We remember their names. We tell their story. We make sure that what happened on July 14th, 1944, remains part of the historical record. Not because it was impossible, but because it happened anyway, and that matters. That will always matter.